the membrane which allows solvent molecules to pass through that but not the solute molecule, such membrane is called as semi-permeable membrane. Is solutions which having same osmotic pressure at given temperature are called isotonic solution. When the particles are combined together, the number of particles decreases. When number of particles decreases, the colligative property also decreases. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the previous session, that is in the 6th session of solution chapter, I discussed about what are colligative properties and the 4 important colligative properties like relative lowering of vapor pressure as well as elevation in boiling point and depression in freezing point. The last colligative property, that is osmotic pressure, that is the 4th colligative property is osmotic pressure. To understand what exactly osmotic pressure, you should know what is osmosis. What is osmosis? So today in this session, I am going to discuss about the 4th colligative property, that is osmosis. My dear student, already you know that what are colligative properties. Colligative properties are the properties of dilute solution containing non-volatile solute. It depends upon the number of solute particle as well as it is independent of nature of solute particle. It is independent of nature but depends on number of solute particles. Next, I am going to explain about reverse osmosis, abnormal molar masses, want of factor and some numericals. Again, in this session, I am going to explain about osmosis, osmosis in natural process, osmotic pressure, reverse osmosis, abnormal molar masses, want of factor, as well as I am going to solve some numericals which are related with colligative properties. Okay, the first I am going to explain what exactly osmosis, why you require this osmosis process to explain osmotic pressure. Okay, now let us consider water in a beaker. I'll take Thistle funnel, inverted Thistle funnel. The mouth of the Thistle funnel is tied by semi-permeable membrane. The mouth of the Thistle funnel is tied by semi-permeable membrane. Inside the Thistle funnel, take concentrated solution of NaCl, concentrated solution of what? Sodium chloride, and keep it for some time. So after some time, when you observe, the level of the liquid in the Thistle funnel rises. If this level is A and this level is B, A it is the level, so it rises to B. Why? The level of the liquid inside the Thistle funnel rises because of the movement of solvent molecules from lower this water to concentrated solution of what? NaCl. Here it is water. Inside the Thistle funnel, there is a concentrated solution of NaCl. Concentrated solution of what? NaCl. The water molecule diffuses through semi-permeable and the level into this Thistle funnel. Therefore, the level of the liquid rises. That indicates what? The movement of solvent molecule from lower concentration to higher concentration, because inside the beaker there is water and inside the Thistle funnel there is a concentrated solution of sodium chloride. Concentrated solution of what? Sodium chloride. Water diffuses from beaker to Thistle funnel through semi-permeable membrane. Therefore, it is lower concentration and it is higher concentration. Therefore, the spontaneous movement of solvent molecules from the solution of lower concentration to the solution of higher concentration through semi-permeable membrane. That is very, very important. Dear student, what is diffusion? The movement of gas molecule from higher concentration to lower concentration. The diffusion of gaseous molecule from higher concentration to lower concentration is called as diffusion. What is osmosis? The movement of solvent molecules from lower concentration to higher concentration through semi-permeable membrane. Lower to higher solvent molecules, so lower concentration in the ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ students? ಮಕ್ಕಳೇ, higher concentration hote through semi-permeable membrane. This phenomenon is called as what? Osmosis. Then question arises, what is semi-permeable membrane? The membrane which allows only solvent molecules to pass through that, but not the solute molecules, The membrane which allows solvent molecules to pass through that, but not the solute molecule. Such membrane is called as semi-permeable membrane. Is called as what? Semi-permeable membrane. The membrane which permits the passage of solvent molecules to diffuse through that, but not the solute molecule. Such membrane is called as semi-permeable membrane. The very beautiful example for semi-permeable membrane are cellophane, parchment paper and pig's bladder. Cellophane, parchment paper, pig's bladder, not filter paper, it is a parchment paper. Cellophane, parchment paper, pig's bladder. These are beautiful examples for what? Semi-permeable membrane. Once again I will repeat, semi-permeable membrane is a membrane which allows only which type of molecules to pass through that? Solvent molecule, but not the solute molecules, Example for osmosis, when you observe raw mango, when you are preparing pickles, when raw mango is soaked in concentrated solution of what? Sodium chloride, the surface or skin of the raw mango is shrivel, it will get shrink due to osmosis, as well as wilted flowers revive when placed in fresh water. Wilted flowers, they revive when it is kept in fresh water. People taking a lot of salt and salty food, okay, people take like Lays, chips, banana chips, potato chips, they contain, and dry fish, they contain more amount of what? Salt. So, the person which will take a lot of salt or salty food, so they experience a water retention in its tissue cells and intercellular spaces because of osmosis, and because of the result, the puffiness of the resulting of the puffiness or swelling is called as edema. Is called as what? Edema. ಈ ಕಾಲ್ಗಳು ಊದ್ಕೋಬಿಡುತ್ತೆ, ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಎಡಿಮಾ. ಈ ಎಡಿಮಾ ಯಾಕಾಗುತ್ತೆ ಅಂದ್ರೆ the person will take more salty foods. Salty food ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಯಾವುದು? ಚಿಪ್ಸ್ ಅಲ್ಲಿ ಸಾಲ್ಟ್ ಇರುತ್ತೆ, ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? ಸೊ ದೆನ್ ವಾಟರ್ ಮೂವ್ಮೆಂಟ್ ಫ್ರಮ್ ಸಾಯಿಲ್ into the roots and subsequently it goes to the shoot system. Root system in the water, shoot system hogodu because of what? Osmosis. Because of what? Osmosis. And preservation of meat by salting and of fruits by adding sugar protects against bacterial action through the process of osmosis. A bacterium on salted meat or candied fruit loses water and shrivels and dies. The meat can be preserved by adding salt, as well as fruits can be preserved for a long time is adding sugar. That is known as what? Candied fruit. The bacterium which is present on fruit and meat, they get shrivel and dies due to osmosis. These all are very beautiful example for natural osmosis. Natural osmosis. Okay. Now after osmosis, you should know about what exactly osmotic pressure. What exactly osmotic pressure? Now let us consider it is a solvent and it is solution. Here they separated by semi-permeable membrane. So now the flow of solvent molecule from the solution of lower concentration to higher concentration through the semi-permeable membrane, that is known as what? Osmosis. Now I want to prevent osmosis. If you want to prevent osmosis, apply external pressure on solution of higher concentration. Solution of what? Higher concentration. Apply external pressure or sufficient pressure on the solution of higher concentration to prevent osmosis. That sufficient pressure or that external pressure is called as osmotic pressure. And it is denoted by pi. pi. Okay, so what is osmotic pressure? One, we can prevent osmosis. What is osmosis? The flow of solvent molecules from lower concentration to higher concentration through semi-permeable membrane is called as osmosis. How we can prevent osmosis? Osmosis can be prevented by applying higher pressure or sufficient pressure on the solution of higher concentration. One, we can prevent osmosis. Osmosis is denoted by pi. Osmotic pressure is denoted by pi. So, osmotic pressure of a solution is defined as the pressure to be applied on the solution of higher concentration just to stop osmosis. Just to stop osmosis. Whatever you want to apply pressure, the pressure must be applied on we have two solutions. One is solution of lower concentration and one is solution of what? Higher concentration. You apply external pressure on solution of what? Higher concentration to prevent osmosis. That pressure is called as what? Osmotic pressure. Osmotic pressure is a colligative property because it depends on the number of moles of solute in the solution and not on the nature of the solute. Osmotic pressure also called as colligative property because it depends upon number of particles of the solute and it is independent of nature of solute. Nature of solute. Now, from experimentally you observe that osmotic pressure of the solution is directly proportional to concentration, that is molar concentration. Concentration should be expressed in molarity. So, pi is equal to Kc. If I remove the proportionality sign, it will K. Pi is equal to Kc. What is K? K is proportionality constant. K is proportionality constant. That K is equal to RT. That K is equal to RT. Pi is equal to Kc. K is equal to RT. So, therefore, pi is equal to CRT. What is C? C is concentration. C is what? Concentration of the solution. NB moles of solute is dissolved in V liter. Concentration is equal to NB by V. That is number of moles divided by volume. So, pi is equal to NB divided by V into RT. W grams of the solute of molar mass MB present in the solution, then NB is equal to WB divided by MB. Pi is equal to, when you substitute this, pi is equal to WBRT divided by MB by V. MB is equal to WBRT divided by pi V. How? The molecular mass was the formula. MB is equal to WB RT divided by pi V. What is MB? MB is molar mass of solute. MB is what? Molar mass of what? Solute. WB is mass of solute. T is absolute temperature. R is equal to universal gas constant. Pi is osmotic pressure, V is volume. V is volume. Therefore, how can you, the molecular mass of solute as well as osmotic pressure are related with each other? So, MB is equal to WBRT divided by pi V. MB is equal to WBRT divided by pi V. When you observe this MB is inversely proportional to pi. What is pi? Pi is osmotic pressure. What is pi? Pi is osmotic pressure. Osmotic pressure. Okay. Next, I will consider two solutions A and B. Two solution A and B. When the osmotic pressure of A is equal to osmotic pressure of B, such solutions are called as isotonic solutions. Such solutions are called as what? Isotonic solutions. Now, what are isotonic solutions? Solutions which having same osmotic pressure at given temperature are called isotonic solution. Okay? Two solutions having same osmotic pressure. If I consider two solutions A and B, pi A is equal to pi B, pi A is equal to pi B, then A and B are called as what? Isotonic solutions. Isotonic solution. Example, RBC. RBC is isotonic with 0.9% NaCl solution. This 0.9% NaCl solution is also called as normal saline solution. Also called as what? Normal saline solution. Normal saline solution. What is normal saline solution? 0.9% of NaCl solution is called as normal saline solution. If the sodium chloride concentration is 0.9%, mass by volume percentage, mass by volume volume percentage. Such solution is called as what? Normal saline solution. This normal saline solution is isotonic with red blood cell, RBC. That's why in intravenous injections, instead of distilled water, while giving injection, that is, they can be dissolved in normal saline solution. Why injections are dissolved in normal saline solution? Because normal saline solution is isotonic with RBC, red blood cells. Okay. Now, when the osmotic pressure of two solutions are equal, they are known as what? Isotonic. If osmotic pressure of one solution is greater than that of the other, pi A is greater than pi B, the osmotic pressure of A is higher than that of the osmotic pressure of B, then A is called as hypertonic solution. A is called as hypertonic solution. If pi A is less than pi B, then A is called as hypotonic solution. Students, what are isotonic solution? Pi A is equal to pi B. Please remember three cases. Pi A is equal to pi B. Pi A is greater than pi B. Pi A is less than pi B. When two solutions osmotic pressures are same, such solutions are called as isotonic. When a solution whose osmotic pressure is higher than that of given solution, other solution, is called as hypertonic. RBC, say RBC is placed in seawater. RBC is placed in, these are the RBCs. Are you observing the red color? These are RBCs. When they placed in seawater whose concentration is more than 0.9% of what? NaCl solution. Again, water passes out of the cell, water diffuses out of the cell, the cells get shrink like this, the cells get shrink. So, this is called as what? Hypertonic solution. What are hypertonic solution? Solution whose osmotic pressure is more than that of other solution is called as what? Hypertonic solution. What happens when RBCs are kept immersed in NaCl solution whose concentration is more than 0.9%, whose concentration is more than 0.9%, water diffuses out from the cell and it will get cell get shrinks. Solution whose osmotic pressure is lower than that of given solution is called as hypotonic. Example, when RBC is placed in hypotonic solution, they swell, even burst due to the inflow of water due to osmosis. Therefore, here you observe, here there is a shrinking of cell, here there is a swelling of cell. Why there is a swelling of cell? Water diffuses into the cell. Why here shrinkage of cells takes place? Water diffuses out of the cell. Therefore, here I explained three types of solution: isotonic solution, hypertonic solution, hypotonic solution. Isotonic solution, osmotic pressures are equal to solution. Hyper, one solution is greater than that of other solution. Hypo, one solution is less than that of other solution. Okay. Now, reverse osmosis. The name itself gives the definition of reverse osmosis. Osmosis, now reverse osmosis. What is reverse osmosis? Reverse the direction of osmosis. Reverse the direction of what? Osmosis is called as reverse osmosis. What is osmosis? The movement of solvent molecule from lower concentration to higher concentration. What is reverse osmosis? The movement of solvent molecule from higher concentration to lower concentration. How can you reverse the direction of the osmosis? The direction of the osmosis can be reversed by applying pressure. Pressure which can be greater than pi, osmotic pressure. So, the process of reversing the direction of osmosis by applying the pressure higher than the osmotic pressure to the solution of higher concentration is called as reverse osmosis. You have to apply pressure on solution with higher concentration, but that pressure should be higher than that of osmotic pressure. Then the direction of the osmosis get reversed. So, before applying pressure, the solvent molecule diffuses from lower to higher. After applying pressure which is greater than osmotic pressure, the movement of solvent molecule get reversed. That is, solvent molecules starts to flow from higher to lower. That is called as reverse osmosis. During reverse osmosis, the pure solvent flows out of the solution through semi-permeable membrane. Reverse osmosis used in desalinization of seawater. reverse osmosis used in desalinization of what? Sea water. What is desalinization? DE means removal. Removal of salt from sea water. It can be done by more than, when pressure more than osmotic pressure, 30 atmosphere at 25 degrees centigrade is applied to the sea water. Pure water squeezed out of the sea water through the semi-permeable membrane. Here salt water, the pure water diffuses here and will get fresh water through semi-permeable membrane. But here in case of reverse osmosis, not common semi-permeable membranes are used. We have to use special semi-permeable membranes like CTA, cellulose triacetate, CTA, cellulose triacetate, and thin film composite membrane. Thin film composite membrane, CTA, cellulose triacetate, CTA, cellulose triacetate. One more, TFC, thin film composite membrane, thin film composite membrane. Abnormal molar masses. Okay, now I am going to talk about abnormal molar masses. Already we discussed about all the colligative properties. Colligative properties are directly proportional to number of particles. Molecular masses of the solute can be calculated by measuring any one of the colligative property of dilute solution. So, under two conditions. One, solution must be dilute, and solute is non-dissociable as well as non-associable. So, what are the formulas? That is PA naught minus PA divided by PA is equal to XB is equal to XB. Delta TB is equal to KB into M. Delta TB is equal to KB into M. Delta TF is equal to KF into M, as well as pi is equal to WBRT divided by MBV. So, these all colligative formulas can be applicable only under two conditions. When the solution is dilute, and the solute is non-dissociable as well as non-associable. Non-dissociable as well as what? Non-associable. When the solute is non-dissociable as well as non-associable, so it can be calculated only by using this formula. If the solute is associable or dissociable, how it can be calculated? So, for example, I am giving the association of solute molecule. Association means combination. Association means combination. Certain solutes in solution found to associate. This leads to the decrease in the number of particles in the solution. What happens when the particles are combined together? The number of particles decreases. When number of particles decreases, the colligative property also decreases. As number of particles decreases, the colligative property also decreases. What about molecular mass? Molecular mass increases because colligative property and molecular mass are inversely proportional to each other. Colligative property and molecular mass are inversely proportional to each other. Okay. So, when particles in the solutions are get associated, the number of particles decreases. When number of particles are decreases, the colligative properties are decreases, the molecular mass increases. Therefore, the molecular mass determined will be higher than that of the normal value. Very beautiful example for association. Acetic acid undergo association in the presence of benzene. Take two molecules of acetic acid molecule, it become one. Okay, it is called as, when two molecules, it is called as dimerization. It is called as what? Dimerization. Now, the certain solute in solutions are found to be dissociate. When it found to be dissociate, the number of particles increases, colligative properties also increases, the molecular mass decreases. Therefore, the molecular mass determined will be lower than that of the what we calculated from normal value. Therefore, very good example for dissociation. NaCl is dissociated into Na plus and Cl minus. Therefore, in these cases, when the solutes are undergo associable as well as when the solutes undergo dissociation, in this case, we have to introduce introduce one factor I. It is called as Van 't Hoff factor. It is called as, Van 't Hoff's factor. It is called as, Van 't Hoff factor. When we have to introduce Van 't Hoff factor is introduced when the solute is associable as well as dissociable. When the solute is non-associable and non-dissociable, no need of introduction of Van 't Hoff factor. Van 't Hoff factor is denoted by small I. So, when the solute is non-associable as well as non-dissociable, we no need to introduce Van 't Hoff factor. When it is dissociable as well as associable, you have to introduce a Van 't Hoff factor I. Okay, how can I calculate I? I is equal to normal molecular mass divided by observed molecular mass, or I is equal to observed colligative property divided by calculated colligative property. Consequently, introduction of the Van 't Hoff factor modifies the equation for the colligative property. Observe here. So, for non-associable and non-associable, same formula, but I multiplied by Van 't Hoff factor. I multiplied by Van 't Hoff. Same relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure, same formula must be used, but it must be multiplied by I. What is I? I is Van 't Hoff factor. I is Van 't Hoff factor. Okay. I is Van 't Hoff factor. Okay. So, I can be multiplied. When it can be multiplied? It can be multiplied when? It can be multiplied when the solute is dissociable as well as what? Associable. What is I? I is Van 't Hoff factor. Now, I completed all 4 colligative properties. Regarding that, I am going to solve some numericals regarding about colligative properties like relative lowering of vapor pressure, elevation of boiling point, depression in freezing point, as well as osmotic pressure. Now, I will start numericals. Please read the numerical. An aqueous solution of 2% non-volatile solute exerts a pressure of 1.004 bar at the normal boiling point of the solvent. What is the molar mass of the solute? We have to find out what's the molar mass of the solute? MB. MB is equal to question mark. 2% of non-volatile solute means what's the mass of solute? 2 gram. 2 gram. WB is the mass of solute. What is WA? 98 gram. 98 gram because it is 2%. Volatile solute, if it is 2 gram, what about a solvent? Solvent is what? 98 gram. And it exerts pressure of PA. PA is vapor pressure of solution. Vapor pressure of solution is equal to 1.004 bar. 1.004 bar. What is PA naught? PA naught, vapor pressure of water. Vapor pressure of water at normal boiling point. At the normal boiling point is 1.013 bar. 1.013 bar. 1.013 bar. MA is equal to 18. MA is equal to 18 gram. What is a solvent? Solvent is water. Because here it is mentioned aqueous solution. Aqueous solution means solvent is water. What's the molecular mass of water? 18. Now it is related with PA and PA naught is given means it is nothing but relative lowering of vapor pressure. What's the formula? MB is equal to MA into WB divided by WA into PA naught divided by PA naught minus PA. What is MA? MA is 18, WB is 2 gram, WA is 98 gram, PA naught is 1.013. This is 1.013 minus 1.004. Okay. Now, I'll calculate these. Okay. So, 18 twos are 36 by 98 into 1.013. 1.013 minus 1.004 is equal to 0.009. Now 36 into 1.013 is equal to 36.468 divided by 98 into 0.09 is equal to 0.882. Okay. Now 36.468 divided by 0.882 is equal to 41.3 gram is equal to 41.3 gram. This is the molecular mass of solute. What's the formula I had to use? MB is equal to MA into WB divided by WA into PA naught divided by PA naught minus PA. PA naught minus PA. Next, boiling point of water at 750 mm of mercury is 99.63 degrees centigrade. How much sucrose to be added to 500 gram of water such that boils at 100 degrees centigrade? Molar elevation constant of water is 0.52 Kelvin kg per mole. So, boiling point of water means it's a solvent. Therefore, TB naught is equal to 99.63 degrees centigrade is equal to 99.63 plus 273 plus 273. How much sucrose is to be added? That is, we have to find out WB. In a 500 gram of water, WA is 500 gram and water solution boils at 100. Therefore, boiling point of solution is 100 degrees centigrade is equal to 100 plus 273 Kelvin. KB is molar elevation constant. KB is 0.52 Kelvin kg per mole. So, you know that the TB naught as well as TB. You have to find out what? WB and MB. Molar mass of solute, molar mass of sucrose. What's the formula of sucrose? C12H22O11. It is equal to 342 gram. Therefore, MB, already you know that MB is equal to KB into WB into 1000 divided by delta TB into WA. You have to find out WB. What happens to WB? WB is equal to MB into delta TB into WA divided by KB into 1000. What is MB? MB is 342. Delta TB is TB minus TB naught. TB minus TB naught. It is 0.37 Kelvin. If you difference between boiling point of solution and boiling point of solvent, it is 0.37. WA 500 gram, KB 0.52 into 1000. If you simplify this, 342 into 0.37 into 500 is equal to 63270 divided by 0.52 into 1000 is equal to 520. That is 63270 divided by 520 is equal to 121.6 is equal to 121.6. Like, what's the value of WB? 121.6. Next, the boiling point of a solution of 0.105 gram of a substance in 15.84 gram of ether. Therefore, this is solute and it is solvent. Therefore, WB is equal to 0.1050 gram. WA is equal to 15.84 gram. 15.84 gram was to be found higher than that of ether. And that is nothing but elevation in boiling point, that is 0.1 degree centigrade. What is the molecular weight of the substance? That is MB. MB is equal to question mark. KB is equal to 2.02 Kelvin kg per Kelvin kg per mole, Kelvin kg per mole. Okay, kb is okay. You have to find out mb. What is mb? mb is equal to kb into wb into 1000 divided by delta TB into WA. KB is 2.02, WB is 0.1050 into 1000 divided by delta TB is 0.1 into WA is 15.84. If you calculated this, it will come around 133.9. It will come around 133.9 gram. 133.9 gram. So, my dear student, as well as previous problem, you have to solve these two problems. In cold climate, water gets frozen, causing damage to the radiator of a car. Ethylene glycol is used in anti-freezing agent. Calculate the amount of ethylene glycol to be added to 4 kg of water to prevent it from freezing at minus 6 degrees. Kf of water, Kf is given, ethylene glycol Ma is given, Mb is given, so that is 62 as well as, so Ma is water, that is equal to 18. Okay, so now they are given what is the volume of water, 4 kg of water. By using that, you have to find out what is the amount of ethylene glycol which is added, that is WB we have to add it. Same, what is the osmotic pressure of the solution? Pi containing 3.42 gram of WB is 3.42 gram of sucrose in 500 ml, that is volume is 500 ml means it is 0.5 liter at 27 degrees centigrade. 27 degrees centigrade means 27 plus 273 is equal to 300 Kelvin. We have to find out osmotic pressure. What's the formula of osmotic pressure? WBRT divided by pi V. What is WB? 3.42. R value 0.0821, temperature 300. Pi is equal to WBRT divided by MB. What is MB? It is a sucrose. The molar mass is 342 into 0.5 into 0.5 into 0.5. 3.42 into 0.0821 into 300 is equal to 84.23 divided by 342 into 0.5 is equal to 171. So, 84.23 divided by 171 is equal to 0.492 atmosphere. 0.492 atmosphere. So, what is the osmotic pressure? So, this is osmotic pressure related formula. So, my dear students, in the 7th session, I have completed all the concepts of solution. Please go through all the 7 sessions of solution. You will get a complete idea about board exam as well as your competitive exam. Thank you, my dear students. Goodbye.